We're going to use mathematical induction to prove this inequality involving a factorial. So the left-hand side we're looking at is n factorial. Recall the definition of factorial. N factorial means we multiply the integers from 1, positive integers from 1 to 2 to 3 and all the way to the last number specified n. So for example, if we're trying to find out 5 factorial, we're going to start with the first positive integer 1 and multiply by 2, 3, 4, and in this case the last integer specified is 5. And you multiply out, we're going to get 120. Well, in this case, since n is not given, we don't actually know what n is. And so we all know n factorial is multiplying the integers from 1 to n. And the right-hand side is exponential number, and the base is n, the power is also n. So let's try to do the proof by mathematical induction. So we start with the basis case, n equals 1, and because that's the smallest integer, smallest the positive integer n can take. And so replace the left-hand side with 1. Replace the n with 1, we got 1 factorial. So which means we only multiply 1 to 1, and which is just one number. And the right-hand side, we replace the base with 1 and the power with 1. We get 1 to the first power, that's still 1. That tells us the left-hand side is, so we get 1 factorial is equal to 1 to the first, which means the inequality holds for n equal to 1. And next, we're going to do the inductive step. As usual, we assume the formula, the inequality holds for n equal to k. In this case, we replace the letter n in the inequality with k. So we're going to get k factorial less than or equal to k to the kth power. And we're going to try to see what we need to prove. So our goal is to prove the inequality holds for n equal to k plus 1. Again, we increase n from k to k plus 1. And we go back to the inequality that we need to prove. We replace the left side n with k plus 1. We replace the right-hand side n, the base n with k plus 1, and the power with k plus 1. So the left-hand side, it's k plus 1 factorial, and right-hand side is k plus 1 to the k plus 1th power. And so we want to prove this. We're not, at this point, we don't know if this is true or not. So we start with what we know that is true. So we know for sure k factorial is less than or equal to k to the kth. And we compare, again, we compare the two left-hand sides, k factorial and k plus 1 factorial. So k factorial, we know the meaning is multiply the numbers from 1 to 2 all the way to k. And k plus 1 factorial means we multiply numbers from 1 to 2 to 3 to k all the way to the last one, which is k plus 1. So as we can see, they have the first k numbers, k integers are exactly the same. The only difference is k plus 1 factorial multiplies one more integer, which is k plus 1. So we know that this is something we can do. We can multiply k plus 1 both sides. So if we do that, the left-hand side k factorial is multiplied by times k plus 1. Well, multiply k plus 1. I forgot to write k plus 1 here. Multiply both sides by k plus 1. So we put times k plus 1. And the right hand side, we're going to multiply by also the same thing, k plus 1. Okay, again, by the property of inequalities, if we multiply both sides of the inequality by a positive integer, because k plus 1 is positive, and this inequality will still hold. So less than equal to will still be less than or equal to. So now we got matching left-hand side, because k plus 1, k factorial times k plus 1 is exactly k plus 1 factorial, pretty much by the definition. And the right hand side, we need to get k plus 1 in the base and k plus 1 in the power. But what we have so far is k in the base and k in the power. So we're going to try to do some change here. So what I'm going to do is I'm going to increase the base k to, so this base k right here, to k plus 1, and keep everything else. And of course, I'm going to have to use less than or equal to. Actually, it should be strict less than, because k, as we know, k is always smaller than k plus 1. So if k is smaller than k plus 1, when we raise both of them to kth power, k to the kth is going to be still less than k plus 1 to the kth power. And we can multiply both sides by, so we take this and multiply the left side by k plus 1, and the right hand side we keep it and multiply by the same thing, k plus 1. So multiply. And again, it's the property of inequality. If you multiply inequality both sides by a positive integer, it's gonna keep the less than sign or greater than sign. Okay, now we can use the algebra property. When we multiply exponents with the same base, k plus 1, we can keep the base, k plus 1, and add the powers. So we add these two powers, these two here, k and 1, and we get k plus 1. And that's exactly what we need on the right hand side. So if we combine if we just write on the left hand side k plus 1 factorial, and the right hand side k plus 1 to the k plus 1, and omit all the steps in the middle, and that is exactly the formula we proved. So we can say the inequality holds for n equal to k plus 1.